So this is question 2 of the SAMS paper 2 higher tier. It's the sample assessment material for Edexcel GCSE. And these questions do get harder as you go along. It's a ramped paper. It's like a sawtooth like this. So question 1 is easier than question 2, which is easier than question 3 in general. And within the question, the parts get harder. So the end of question 1 part C that we've just done, should be slightly harder than 2 part A, which it is. But then 2 part C will be harder than 1 part C. Okay, so question 2. Figure 2 shows a tank for holding water. The tank has sides 2.4, 2.1 and 1.5 metres. The pressure at the bottom of the tank is 12 kilopascals. State the equation relating pressure, force and area. So this is another equation that you need to know, and it's that pressure equals force over area. And this is one that I often see written wrong as pressure equals force times area, divided by. Calculate the weight of water in the tank. Normally, for weight, I would go to the equation W equals mg, but I haven't got a mass here, so I can't do that. I need to recognise that the force is the weight. So I can rearrange that equation to say that force equals pressure times area. And I'm told the pressure on the tank is 12 kilopascals. That means 12,000 pascals. And the area, it's the area on the bottom of the tank, so it's a shaded area here. So that's 2.4 times 1.5. Put all those together and we get 43,200 newtons as the weight. Part 3, which diagram shows the direction of the forces from the water on the inside of the tank? We are going for B. Pressure is always normal to the surface. It's always pushing against the surface at a right angle. Then part B, quite an involved question here. Figure 3 shows 3 containers A, B and C. Each container contains a liquid as shown. We've got water, we've got mineral oil, and then we've got water again. A and B, we've got that they are the same height. B has got a bigger area and C is a lower height. And they've given us the actual values here. So we can see that A has got half the area of B and C is less area than both of them. The density of the liquids, the water is the same, 1 for both of them, and then mineral oil is slightly less dense. And the depth of water, we've got 50 centimetres for both A and B and 25 centimetres for C, which will be important for the next question, which annoyingly on a different page. So, explain which container has the highest pressure at the bottom and which container has the lowest. Use information from figures 3 and 4. So we need to use the equation pressure equals H rho G, which is at the back of our formula sheet. So that pressure equals the height of the water times the density of the water times G, and G is 10 newtons per kilogram, 10 metres per second squared, as always. So it's the pressure depends on the height and the density. Now, the ones with the highest height are going to have more pressure. So here we've got A and B are higher than C. So A and B should have a higher pressure than C. Then out of A and B, which one's going to have a higher pressure? Well, it's going to be water because it's got a higher density. So H times rho will be bigger for this one. For the smallest one, density and height both count equally. So although this has got a lower density than the water here, because this has half the height, whereas this isn't half the density, this will have a smaller value. So how are we going to write that? Well, I'm writing the equation there. I'm going to say, therefore, pressure depends equally on height and density. A has the highest pressure as it has maximum height and max density. C has lowest pressure, half the height of the others, but B's density is not half that of C's. So I've written that in quite a note form. I would generally try and write that in more of I would probably write the word density in my actual exam. But there we are. So that's trying to explain your thinking for that question.